We did math, we did residential, finished it. We did commercial, we finished it. Now we're moving into the industrial project. The industrial project is that we set up yesterday. See how nice it was, easy to do the whole setup. In order to get you more information about the industrial project, I picked this book, which is the industrial wiring, because it directly mirrors the project that we're doing. So, for example, if you guys look at when you get your book, I know some of you, Karen, you have your books. If you can get the blueprints from your book, you have 2 sheets of blueprints. So you're going to have a site where there's an industrial building that the book is following, and showing the location of that building and a couple of elevations and what's not. Then you're going to have a riser, a one-line diagram that shows how that industrial building in this book is wired. So we have a riser here. And then we have, this is probably the most important one. I'm going to go over it a lot, guys, this sheet right here. As we move, this sheet will show you how the bus duct is routed through the whole building. We have a bus duct in this building here, and it's routed through the whole building. We have a feeder bus duct, a plug-in bus duct, and a trolley bus duct. And I'm sure a lot of you have never heard of these. A trolley bus duct, a plug-in bus duct, and a feeder bus duct. So all these are coming to this floor, and they're feeding machines in this project, exactly, Adam, like the project that we're going to be designing. So if you guys follow this book, it's almost giving you the information how to design a project, our project. Then you get into here, and this is the manufacturing floor, and it shows how the receptacles and the lights are located in the manufacturing floor. The major difference, guys, between the building that you're going to be designing a power system and a lighting system and low voltage system for, this industrial building and the building we have just finished, is one little thing. We have an open floor called manufacturing floor, where they have machines and need to be plugged in and powered. It's the only major difference. And these are all the machines here, and I'll go over this one in details when we reach the chapter. This is a chapter actually talking about the machines and how the bus ducts is laid out here. But I want you to know there is a sheet that has all the bus layout, feeder, and I color-coded them into feeder, plug-in, and the pink is called the trolley bus way. Then the same floor here, the manufacturing floor, has all these string of lights and receptacles feeding this area with multiple panels to feed this manufacturing floor. Then you come over here, and that's how the power is coming to this building. So they're bringing a 1500 amp fused disconnect and a 1000 amp, 1600 amp fused disconnect and a 1000 amp fused disconnect. They're coming into this building to feed the whole building through a couple of buses, plug-in busways, and a couple of panels. And I'll go over this one in details when we reach it. There's a chapter talking about each one of these aspects. Did you guys hear me? So this book, 20 chapters, each chapter takes one segment of this project and talk about it, exactly like the commercial project did. This is the site. Here's my building here. Remember that site shows all the building, the parking lot, all the lights for the parking lot. Shows also elevation, all the elevation in this building. They have a lightning protection system. And guess what you guys are going to be doing? You will be doing a lightning protection system for your building. And here's a lightning protection system already designed for you, and it talks about how you do it. So can you guys see the correlation between this book and our project? So we didn't pick it up just because. It's directly related to the project that we have, that you're going to be designing. Here's your lighting system. All the symbols that you're going to be using here, a couple of elevation. Why the elevation is so important, Adam? When you do your lighting calculation, you're going to come back to me and say, Chad, I'm using visual. What's the height of your ceiling, right? Well, every building, the architects will give you the elevation for that building. So you know what the height of the ceiling, the structural ceiling, the false ceiling, the lights, and what's not. So you can run your calculation. Okay, so when you guys get your book, you're going to have, like I said, 2 sheets. You will have 2 sheets. These are front and back, by the way. They're not 4 sheets. There are 2 sheets front and back. I have 2 sets of them, so I just laid them all side by side. You'll have 2 sheets with 4. One will be the site, one will be the riser coming in, the other one will be the most important thing, bus duct, plug-in, and trolley. Trolley just moving, as well as the feeder, and the other one will show the receptacles and the lights in this manufacturing floor and all the panels. Any comments, guys, any questions about what this book is going to have? So Every chapter, 20 chapters only, so 20 lectures will be in this book, guys. Very simple, very easy. Please read it. Read it once in your lifetime. It gives you more information about how to design a power system for an industrial building. Any comments, guys, about what you have? Any comments, any questions about what you have? Does that make sense? We have 20 chapters following this blueprint. So, Adam, when you talk about the industrial project in the book, that's what I'm talking about, because we have two projects. We have one you guys are designing and one we are analyzing and following in the book. So don't get confused between the two. Okay, so chapter 1, guys, talk about the plans and the site. Talk about this sheet. That's what chapter 1 is. Talk about this particular sheet. So I'm going to have a few things just to show you. Let me grab, this is okay. Let me grab, all right, grab my pointer. I think my pointer, I hope my pointer works. There we go. Okay. So, like I said, 20 chapters. Chapter 1 talk about the plans and the site work. Like I told you, there are 4 plans. There's one for the site, one for the riser, one for the light, one for the fast duct, and one for the light and the receptacle. A few things, guys. The site should remember yesterday you guys did the setup for the site, right? So why do we have a site? It gives you the orientation, the physical, mechanical orientation of the building in the lot. So you know where the power is coming from, where the utilities are coming from. So site plan determine the location of the specific, the most important thing, location of specific items, like the phone line coming to the building, the power coming to your building, very, very important. Material for the, so selecting material for the electrical site work. So when you become a project manager, Adam, you're working at Michelle Cooley. I don't know if you probably will be on a job site, but if you work for electrical contractor, guys, the first thing you're going to choose a location for your trailer on this site, right? So the plot right here that you have, it will give you the location where you're going to put your trailer in this big picture that's called construction. So it's a big information, as well as your material underground. Identify the underground wiring methods. So now the first thing when they dig, they're going to build the stadium, right? You know what the first thing they're going to do? They're going to dig the ground, right? Take the big hole in the ground. When they make this big hole in the ground, the electric, now we don't do that big hole in the ground. We as electrical contractors and engineers come and we do two things. We put our grounding and bonding system there, right? And we also put our conduit system, underground conduit system. We put our conduit system. So that's very, very important, guys. We need to know where the lot is and how how it's laid out in the building. And every chapter, every book that we guys talk about the SI system, since we use the standard system in the US, it's always nice to talk about the SI system, the international system of measurement. Calculate metric measurement. This is every chapter that we do. We keep emphasizing on the metric system because it's closer than you think. You work in an engineering firm, guys, you will be using metric system. You could be using metric system for certain applications. So that's what we're trying to do in this chapter, guys. Okay, now I know, Karen, I don't know where you're going to end up working, maybe for electrical contractors, for engineering firms, wherever you go. If you're working for contractors, especially electrical contractors, you must inspect the site plan and determine the following. So here's my site plan right here. You're looking at, you need to determine the following. Location of the industrial building on the site. Here's my building right here. Here's my telephone coming in. Here's my power. Can you guys see where the power is coming in here? It's showing you where the power coming in, where the telephone line's coming in, how your light is located, the outside light, so important. You can't do anything without having the site, right? Does that make sense? You guys have done the site for the commercial building as well. Underground wiring system and raceways. You need to determine where the underground wiring systems and raceways and manholes. I don't know if you guys look right here. There is a manhole right here that's coming for the power system. There's another manhole right here. There is a telephone service pole coming in right here. There's a couple of light, direct buried cable for all the lights right here around for all these buildings. So it's so important, guys, on the site. You know what a manhole is? A big hole in the ground. They bring conduits to it with wires so you can go from point A to point B. It's like a big junction box. Another one that they use is also handhold. Handhold, you can stick your hand in it. Manhole, a man or a woman can walk into that big hole in the ground. So when it comes to the site, very, very important. I don't know if you guys can see them right in here. So Adam, some of the questions that you guys may ask the homework questions, they will tell you where's the location of the manhole. Right here. Here's the manhole. So where's the phone? Here's the phone. So looking at the site and identifying the location is so important, guys, for us as electrical engineers and electricians and estimators. Next segment, you guys are going to be doing estimating. When you do estimating, you're going to have a site like this. You're going to go take off the feeders coming to the building. You need to identify and understand what the symbols are used. Trailer stores materials and tools during the construction. Another thing you need to do, they will give you a trailer, guys. So you need to situate in coordination with the superintendent there and the general contractor. You need to coordinate the location of your trailer on that lot while you're building the stadium. So that will be coordinated with the general contractor and superintendent and what's not. So the site is a big deal. Can I get you guys to understand the site is a big deal? You know, that's your start point. Here's where the location of the building, all utilities coming in. Here's my trailer. We're going to do the grounding. We're going to put our underground conduits. And that's where the site comes very, very important. And light for the parking lot and what's not. Okay, so refer to the existing points such as building location, center lines of the street. Another thing, guys, I don't know if you guys can see it right here and right here. These are the center line of the street. They orient the building from all directions. Look, remember, when you have a building, Karen, you have a lot most of the time, a city lot or a county lot or what's not. So that lot, that could be half an acre, or 5 acres, or 10 acres, right? Still a lot. You need to orient your building from the streets. The area will be surveyed. All the areas in the U.S. have been surveyed, right? And then you're going to orient your building in that lot based on the streets that you have. So that's very, very important, guys. Property lines and center lines of the streets. So it will give you property lines, center line of the streets can be used to locate the building. And other side improvements and what's not. So these are, like I said, here's my building, here's the center line all around the building. So I can, to scale, I can tell the length of my feeders coming to my building. Any comments, guys? Any questions about the site? Any comments, any questions? So please, I can't emphasize the word please enough. Read it, guys. Very, very important if you're going to be a good designer. Okay, for the explanation of the site, here's all the symbols that they use, guys, for the site right in here. And for this one, I'm going to skip that one and go directly into this card, into my, here's a symbol that they use for the site. I want you, they always start, Adam, with something called benchmark. Benchmark, that gives you the elevation. When I want to build my building, here's my elevation, and I want to measure everything based on this elevation, above or below this benchmark. And the benchmark, typically, here's my benchmark right here. They call it the benchmark right here. The benchmark for this building is 745 feet and 0.68 of a foot. These benchmark, we measure everything, guys, based on the sea level, right? That's how we measure. Like, I think, what are we, 700 or 800 feet above the sea level? So that's how we measure things, above the sea level. So they take a point on the lot and they say, this is how we're going to measure it. This point is going to be, say, 746 feet above the sea level. And from this point, that's my benchmark for the height. And everything will be measured based on this point. So that's called benchmark. You can see, guys, the elevation for it. There's a number, how many, as well as the elevation. There's a test pouring number, here's test pouring and what's not, that for the foundation. Existing spot elevation, look at all the symbols that they use, and again, you don't have to look at all of them. Existing contour to change. If you guys see a line like this, it will tell you that this line right here, this area will be excavated. So if you see a line, like where would that be? Here, right here. All these will be excavated. All these area will be excavated. Means we will bulldoze that area. So these are a couple of symbols. Existing contours to remain. Can you guys see if it's straight line? Contours. A contour line, guys, it shows the elevation of that area. The whole area have the same elevation. If it's dashed like these, it will be like 240 here. It will be existing contours to change. If it's straight line, it will it will stay consistent. If it's a thin straight line like this, new, so you're gonna have a new elevation. So these are some of the symbols that they use. Here's a manhole, fire hydrant, catch basin and what's not, rim elevation, power and telephone poles. These are all the symbols that you're gonna encounter on a site. Light sites, that's the parking lot and what's not, existing trees, water, look at this, a line like this, water line, telephone line, power line, gas line, fuel, oil, sanitation, storm, combined sewer, drain. So they will give you the other disciplines. It's so important, guys, to understand in the site, because you're going to bring your power lines and it's going to go right through a storm pipe. Can you do that? You can't do that. You have to coordinate between the other disciplines. So I can't emphasize I know this is above your head now because you guys not project manager. When you become a project manager, that's what you do. You need to coordinate between your duct bank underground with the sewer line and the storm water on the site and everything else. New building, existing building to be removed. So all these the symbols, non-electrical and electrical symbols that you're going to see on the site. Non-electrical symbols and electrical symbols that you're going to be seeing on the site. Any comments, any questions, guys? Any comments, any questions about these symbols? You don't have to memorize them. Please remember that you always can. If you see something, the most important thing is the utility lines, like the telephone lines, power lines, gas lines, water lines. You need to coordinate in the underground. You're bringing a huge power to a building, guys. We're one utility, electrical and phone or telecommunication. There are other utilities that have to bring their power into the building, like in the gas lines and fuels and sanitation and what's not. So I hope I convinced you with that one. So that's a few symbols that we can use. Any comments? Any questions? How was your birthday?
Good.
Good?
Really good.
That's good. Did they feed you good?
You know what? Because I had that archery league thing last night. My wife and daughter went out to eat with her parents. So, but my father-in-law gave me for my birthday a pocket helicopter.
Pocket helicopter.
Yeah, so it's literally like this. It's literally like this thing. And it's got like 7 LEDs all the way across it. And
Boy.
yeah, and it's remote control because he was just messing around. Like, I guess he got one and he thought it was just kind of funny to have, so he gave one to me. So
That's cool.
planner helped us out my dog last night.
That's cool. That's cool. I'm glad it worked good for you. Contour lines, guys, we talked about that contour lines. It looks like this. It shows the elevation. So every point on this will be at the same elevation. They call it contour line. Indicate existing and new grading. So you either existing or new. So what they do, they shave the ground, right, in order to put a building. So they show what the first elevation before and after. So you're going to see all these contour lines. Trenches must be provided with enough depth. Why do we care about this one, guys? Because if you're going through a couple of contour lines and they're at different elevation, by the time your pipe reach here, if you start with 3 feet here, by the time and you're going up, you might end up with 1 foot here, right? Because we're going up. So you have to know when you drill your trench, when you put your trench in the ground for your conduits, you need to know what the elevation. Are you going up? Are you going down? Or is it just straight? So this is big deal. Trenches, you have to have enough depth for them to ensure that you're not going to start with 3 and end up with 1 foot after they do the final grading for the area. Benchmark, we talked about this one, guys. This is an elevation reference point. It's reference point from which all elevations are located. Elevations located, reference point, they call it the benchmark. Now these are the surveyors. We don't do this, right? The surveyors will do that. But established by the surveyors, not you and I. The responsible primarily for doing surveying for the site. They survey the site, they have a benchmark there. How do they do this one? It's determined by something called city datum. or the mean sea level, above the sea level. So every city has its point city datum. That's how they decide the elevation for this city, which is basically based on very simple thing: are we above or below the sea level? Are we below the sea level or above the sea level? Are there places below the sea level? Anybody remember one? I swam in one. Dead Sea. Your friend Ched floated many times there. I think it's 300 meters, if I remember right, meters. So multiply by 3 below the sea level. When you drive there, if you've ever been there, your ears pop. The pressure is so high. So it's really interesting. So we go above and below the sea level. Cool? Everybody understand that one? That's how we measure the elevation. We have a benchmark. That benchmark is 750 above the sea level, right? And then from that benchmark, we measure everything else. Here's my benchmark, guys, for this project. Derek, I just put the blueprints right in here. My benchmark is 745.68 feet above the sea level. Elevation. Why do we care about the elevation like this? I told you we need to know how to run our calculation. Careful attention has to be given to the elevations for the proposed building because of simple thing. Derek, you were asking me, you're going to do your calculation for the lighting, right? The first thing I'm going to say, Chad, what's the height, the structural height, and the height of the fixtures for this building? Where are you going to get this info? From the elevation, right in here, gentlemen. Here's the elevation for this building. For example, if I want to find floor 1, floor 2, floor 1 located at 751.5, floor 2, 765.5. So you subtract them from each other, and that will get you the elevation of this floor. The elevation of this floor. So the plans will give you a lot of information, guys, related to the industrial project information, valuable information as an elevation, the location of all the windows, the location of all the views we have. We have views here, front and north and south and what's not. So when you locate your lights, you don't want to locate your lights right in the middle of a window. So location of the windows, guys, all these determined by the elevation of the building. Plans or plus or minus the reference to the. So when they do them, sometimes they go to the benchmark and the reference like we are. Here's a benchmark. We're 10 feet above the benchmark or 10 feet below the benchmark. They reference them 10 feet above or below the benchmark. In this elevation, guys, what they do, here's the elevation for this building. They're giving you directly the elevation above the sea level. And in order to find the elevation of this floor, guys, all what you have to do is subtract 778.5 from 765.5. That will get you the elevation of the building. Who's responsible for this work, guys? Not you and I, the architects. What's our job? Our job, guys, is to understand it. Be able to understand. Here's the two numbers right here given. Subtract from these, it'll give you the structural, the elevation of the height of your ceiling, or the height of your floor. Okay, so we talked about the elevation. There's something called invert elevation, guys. Kind of a weird term, invert elevation. It's when you have a manhole, it goes to the lower conduit of your manhole. So Karen, here's the lower conduit inside my manhole. They go down to the bottom of the conduit. The elevation of the bottom of the conduit is called in the lower conduit. The bottom of the lower conduit in a manhole is called invert elevation. Entering the manhole. So the lower one, the bottom of the lower one. The lower edge of the lower conduit. It's called invert elevation. And Adam, guess what? There is a question in that. What is an invert? So the lower conduit, the bottom of the lower conduit. It's called invert. Scales. When we use scales, guys, there are two scales that we use in. There's something called the engineering scale. I have both of them. Where did it go? Here you go. There's an engineering scale and an architectural scale. This one is called engineering scale. It's 10, it goes by 10, 50, 60, and what's not. The architectural scale, guys, goes by 1/4 and 1/8 and 1/16. That's what we were doing when we were scaling yesterday, the architectural scale. So when you see something like 10 here, so when you see a 10 here, so it means every inch, an inch is equivalent to 10, an inch is equivalent to 10 feet. 20, which means 1 inch is equivalent to 20 feet. 30, same thing. 1 inch is equivalent to 30 feet. So that's your multiplication of these. The architectural scale, 1/8 of an inch is equivalent to 1 foot, or 1/16 of an inch is equivalent to 1 foot, and then you multiply that one by 12 and get you the multiplier. So anyway, so we use scales all the time, guys, to get information. And knowing you guys, knowing Revit, we use the architectural scale all the time. So, any comments, my friends? Any questions? Any comments? Any questions? Comments? Questions? Comments? So that's the scales that you use to get information. Site work, be aware of all the requirements. When you guys doing, since probably Derek, you might end up working for engineering for contractors. You might, I'm not sure now with the whole changes. When you start doing the takeoff, be aware of all the requirements in the plans and specifications. So that it gives you a lot of information, especially when you do takeoff for a project. You have to make sure that everything, coordination with other disciplines is done, the elevation is okay, where the powers and the utilities are indicated, should not conflict with the site of other trades. So the most important thing, like I said, in the site or elsewhere, guys, coordination with other disciplines, other trades, underground or above ground. Any comments, my friends? Any questions? Comments, questions? It's not Friday. So now we said when we have what two things we do when we start digging for the stadium, Derek, right? We're going to dig a big hole now. We're going to put new Viking stadium soon. They are digging. The first thing you need to do is two things. Number one, you're going to coordinate your underground ducts, right? Coming to the stadium. And number two, you're going to test your grounding system. Grounding and bonding, guys, I have tons of information later for grounding and bonding. But the first thing you need to do, establish for any building, is a grounding and bonding for that building. That's your first line of defense. So what does the grounding and bonding do, and why it's related to the building? You have no building yet. So you have to go and test your grounding resistance, because the lower grounding resistance, the better the grounding system will be. If it's not low enough, you have to treat the soil to get it lower enough. So the grounding system, guys, will protect you from transient currents, electrical noise minimized, and lightning, as well as the first line of defense when it comes to your electrical safety shock hazard. So now we have a big hole in the ground on the site. We're going to go test the grounding system. I'll show you how they do it in a second. Okay, effectiveness of the grounding system depends on the earth resistivity. So we have a big hole in the ground on the site. Let's go test that one. Why we care? Because if the resistivity is very high, like sand, the grounding system is awful. If your grounding system is awful, is bad, then it's unsafe system. So it's unsafe. It's not safe enough. Okay, resistivity varies even with small areas. So when you have resistivity, guys, the soil type, if you have wet clay type, that will get you wet, saturated with water, get you very low resistance. If you get the dry sand or rocks, that will get you very high resistance. Does it make sense in terms of earth resistance? Moisture content, like I said, more moisture is better. Electrolyte content, the salt and what's not, and temperature. If you are in the middle of a desert, good luck getting a really good low resistance. The more moisture you have in the ground, in a clay, the better the resistance the lower the resistance would be, and a better grounding electrical system you have. So that's why in a lot of communication system, what they do, Matt, when we do grounding system, they have chemicals in certain holes in the ground, and they keep adding to them to maintain the resistance below 5 ohms or less. In the old days, what they used to do, I don't know if I have the picture here. Okay, I'll have the picture. In the old days, guys, they used to have a 100-watt lamp between the ungrounded conductor and the grounding conductor. And if this light is right, the grounding system is good. I've done that a couple of times. You take a hot 120 and take it to the ground rod and disconnect the ground rod from the grounding system. And is the light on, fully on? Yep, good system. So it's kind of a rule of thumb. Is it good or not? It doesn't give you a lot of information, though. No actual resistance is measured. It's just an indication. Ground resistant testers. There are There are testers that can test the ground resistance, guys. It measures the actual resistance of the system. Three main tests you can do. One of them is called Wenner, the 4-point, and the 3-point follow potential, and the clamp on. Three different grounding systems that they use. So here's the first grounding system, guys. This is the Wenner 4-point. What they do, they have a machine like this, and it pumps potential. It pumps current into this area, into these two. These are rods. They place them away from each other. All these are lined up. They send current from this machine in here, and then they measure the voltage here. Right? It's a machine, have 4 wires coming out of it, shoot current into these rods. These rods are placed away from each other, 10, 20 feet away from each other. And then they measure the voltage drop between them. By measuring the voltage drop, guys, and knowing what the current that's going through the ground, they take the current and the voltage, divide them by each other, and you get you the resistance. And they make them, they do them in a multiple location. Not just in one location, multiple locations. So you can see that's how they test the resistance of the ground. So multiple locations to get you a better application of these. So that's the 3 points. There's another one that they do. It's called this is the 4-point. The 3 points. All what you're looking at these are all rod. Here's the grounding rod of your system. That's your building. And then what they do, they have another grounding rod right here, and a third grounding rod right here. And then they shoot the current. They shoot the current into that grounding rod, and again they measure the voltage. They measure the voltage between these two rods, and by measuring the voltage and knowing the current that's going through the ground, same thing. They find the R, the resistance, and they keep driving these rods in different locations. Here's my first rod, second rod. This is the rod for the building, second, third. And they keep going through these, and they keep them as far away from each other, at 80 feet away from each other, in multiple location, multiple direction. Shoot the current, measure the voltage, calculate the resistance. Shoot the current, measure the voltage, calculate the resistance. When you have multiple values, what do you do? Multiple values. What do you do to get the real value or close to the real value? Average them. So they average them, guys, and they get you, oh, your site is 4.5 ohm. Or 5 ohm, or 25 ohm. Typically, the code requires you to have 25 ohms or less. If you work for telecommunication companies, typically 5 ohms or less. That's considered a good ground resistance. A good ground resistance. Any comments, guys? Any questions about? I mean, I know you're not in the field, but when you go, Karen, and work in the field, you might see them digging all these and measuring the ground rods and resistance. That's how they basically do it. And there's a criteria about how far these have to be away from each other and what's not. So there's a few criteria about the distance between these rods. The distance between these rods. Of course, the easiest one. Now, three methods. The easiest one. This is the clamp on. The clamp on is the best and the easiest method. Look how easy this one there. This one. It's clamp on meter. Have you guys used a clamp on meter with us? Clamp on meter, like measuring the current. Instead of measuring a current, that clamp on meter, guys, have 2 coils in it. One coil, believe it or not, shoots current. It shoots current. The transformer shoots current right into the rod. So you will shoot from here current right into the rod. Okay, and then measure another transformer or coil can measure the current that's coming back. So by shooting current and measuring the current that's coming back, they will determine the resistance of the grounding system. This is probably the most preferred method. Because you don't have to disconnect or interrupt the grounding electrode system in your building. And they use different frequencies that they shoot, guys, like 2000 hertz, not 60 hertz when they shoot it. So 3 methods to test your grounding system. Very, very important. The most common one is the clamp on. Moving away from the ground. Why do we have the ground here? Because when you have a big hole in the ground, it's easy to measure the grounding system. Go to all these points. On the site, guys, there's also notations that tells you a lot of information, identified as asterisk followed by a number. So so asterisk 1, it will tell you, for example, area to be utilized by the water companies and what's not. So there's more information. Hash mark indicate that the section of the elevation will change. If you see a hash mark, that will meaning if you look at an elevation like this elevation will change. They'll shave it. If you see an elevation that's dark like this elevation, dark elevation, heavy lines, this is new elevation. So let's just say that was 900 feet, this one 800 feet. So we're digging basically 100 foot down. We're going 100 foot down. 100 foot down. Another thing, Karen, that we do on the site also, they show telephone service and electrical service and what's not. Here's an example of a telephone service coming to your building, guys, from the phone coming underground, coming from the top all the way going underground into treated pole, pole cab, and fish wire. They have the fish wire, so you can fish your wires right through it, all the way through the 18 inches depth of the conduit. They're going to pull your phone wires or coaxial cable. So this is a good detail to show, when we talk about details, a good detail, guys, to show how you're bringing an overhead phone line, that is an overhead phone line, into underground, bring it underground into your building with the detail. Showing all the details, long sweep, like look at the location E, which is the elbow there, grading and what's not. The height is 8 foot by 8 foot protection for your cable. Any comments, guys? Any questions? That's how they're bringing that phone line into this building from an overhead phone line. If it's underground, typically it will be through a handhole or manhole. Now your underground cables, guys, direct buried cables. There is a direct buried underground cables, 24 inches with dirt. And this isn't that what the detail that you guys did for me? That's exactly what you did, your details. Direct buried cables are inside the conduit, and we buried them at cables approved by direct. They had direct buried, and we have it treated so you can see all the sand that they put there, and then they put the film into it. So the last thing we're going to do is put a cable, guys, and start throwing all these rocks at the top of the cable. So they put the cables in the trench, and they put sand or what's not very smooth fill over it, and then you put the rest of your fill, because you don't want to start throwing rocks right at the top of your cable and damaging them. These are the proper installation. When it comes to bigger systems, Karen, they don't direct bury them. They put them in ducts, and encased concrete ducts. So here's how they do it, gentlemen and ladies. They have you have ducts over here, and inside these ducts is concrete. You can see the whole concrete here, and then they bury them at 6 inch all the way to 18 inches, minimum 6 inches for rigid metal conduit, 18 inches for other raceways, and 12 inches with concrete encased. If you have a concrete encased, you have 12 inches. So here's where the different elevation, if you have a rigid metal conduit 6 inches, 18 just conduit by themselves, you encase them in concrete, all what you need is 12 inches. And typically in a 4,000 amp switch gear, guys, that's what they do. In a 4,000 amp switch gear, they encase them in concrete. Okay. So all this information, guys, is coming from 300.5, the elevation, especially table 300.5 requirement for the elevation underground. So please refer to this one. Installation of rigid metal conduit is coming from article that talks about it. PVC is your conduit of choice, is coming from this article. Each one of these wiring methods, NDC code book wiring methods, have its own article, as you know, and it will tell you if you. Can I bury rigid metal conduit? Yes. Has to be treated for underground, but you can bury it. But if you are going underground, what's your conduit of choice? PVC Schedule 80. Conduit of choice. That's right. Concrete encased. If you have a 4,000 amp switch gear, you encase them in concrete, and you pull your conductors inside them, and you bury them with 12 inches of dirt, and call it a day. Here's the manhole. When we use a manhole, guys, if you go downtown Minneapolis, it's full of manholes. And manholes is a place where a man or a woman can walk in and work on these. So look at them. So here's invert. Remember that bottom, we said that invert elevation? Here's my conduits and wires coming in, guys, here. Here's cable racking. You can rack your cables here. Pulling, you can anchor to pull. You have a rim here and a cover. made our concrete. You have a drain, so the water can seep in, sit in here, and you can drain directly out. They use them a lot, guys, underground, so you can bring underground cables, major cables, and go from point A to point B. Um, downtown cities, guys, is notoriously famous of manholes. There's either manhole or handhole. Handhole, little hole in the ground that you stick your hand and pull for smaller wires. Manhole, bigger hole that a man can walk into it or get into it. You guys have used this one a lot with me. If you have for lighting standards, since we're on the site, typically they have a standard like this where you can have your bolts. So this is where your fixture is going to be sitting right in here, right? On the pole, you bolt your pole here. Can you guys see how you have a grounding electrode conductor coming in here to ground tied to the bolt over here, and you bring your equipment grounding conductor. When you bring your equipment grounding conductor, you tie it also to the ground rod. So what they do for sites, guys, they have a lightning, an auxiliary ground rod right next to the light, typically every other light. That's for lightning protection. So if a lightning hit the lighting fixture on the pole, it will hopefully dissipate directly right next to it, doesn't get into the building. So that's a foundation. This is all concrete foundation. You can see the depth of that concrete foundation and what's not. This is a good example, 1 foot elevation or even higher. It gives you to show when you build this foundation, guys, for your poles up there. That's what you give for the concrete people to go mount them, and then you bring the pole. If you're a contractor, this is a major thing, guys, because that's what you're going to be coordinating. You do the foundation for these poles, and then you bring that pole, and you sit that pole on the top of the bolts, and you bolt these poles, and you're done. And you have a little chamber there, guys, that they have here. You open that little cover, and you do your wiring, fuse it, and you do your wiring. The rest of them, guys, is just SI to metric standards and what's not. So customary standards into the metric standards. So I'm going to highlight one here, which is basically the 1 inch. 1 inch 25 millimeter SI units and what's not 25.4 conversion between SI and the metric. There's two types of conversion, guys. There's something called soft conversion, and there's the other thing is called hard conversion. These are directly from the NEC code book. Hard conversion, this book was made based on an inch. So this book say, I don't know, a foot at 12 inches by 8 inches. So if I want to do a soft conversion, I take the 12 inches, multiply it by 2.5 and find how many centimeters. So you do multiplication to find it. That's called the soft. The hard is the manufacturer of this book. They will go actually redesign it based on the metric system. So they readjust it to be, say, I don't know, 25 centimeters by 10 centimeters. That's hard conversion. So hard conversion, it's redesigned to the metric system. Soft conversion, designed to the standard system, converted calculation-wise into the metric system. It's a big deal, guys, if you deal with equipment coming from overseas. It's a big deal. Okay, trade sizes. You guys have known that many times. When you say, look at this. This is half an inch, different type of conduits. And look at the interior diameter of these. They're all different. Can you guys see that? They're all called half an inch. Electrical metallic tubing, electrical non-metallic tubing, flexible, metallic, rigid, and intermediate. All of them. And look at how all of them, guys, have different type of interior, but they're all called half an inch. That's why a half an inch rigid, guys, will have different number of wires inside it than half an inch EMT conduit, because the interior diameter is different, the thickness is different. So look at the EMT here, 0.622 all the way to the rigid. What's the rigid? 0.63. The interior of the rigid is 0.632. So the rigid have more interior diameter than the EMT. Look at the electrical non-metallic tubing, 0.5, the smallest. And look at the intermediate. Intermediate has a bigger. So you can see. So that's why they call them all half an inch as a trade size. A couple of guide to metric usage, guys. The prefixes that we use. The most important thing is megawatt or kilowatt. These are very important. Millimeters or milliamps. These are very important units they use. And here's the multipliers that comes with each one of them, with each one of these units. So, and we covered these. We went over these a couple of times. Okay, so any comments, guys? Any questions, comments, questions? There's conversion between metric and standard equation. Do you guys remember that little converter that I gave you at the end of the, at the beginning of the school year? If you don't, it's on my favorite on network. I love it because you can convert between from any unit to any unit, mass, temperature, length, volume. So you plug in the numbers, but here's a couple of multipliers to convert between any of these two. So that's what I have. I want to show you a couple of other pictures, guys, and then see if we missed anything. Okay, we talked about this one. Grounding, believe it or not, when it comes to grounding, guys, I don't know if you know, the utilities go ground and neutral at multiple locations. The utilities go ground and neutral at multiple locations. And you ground also your neutral right here. Can you see that? So utilities will ground their conductors. Adam, since you're an electrician, you care, and this is how they used to measure the impedance, guys. So they bring a 120 here, and you tie it to this side. From this side, you go directly into the ground rod. And if this goes on, good, this means you have a good grounding system. That's just an indication. It's not really a good, reliable way. Here's the reliable way, guys, of the 4-point. And we talked about the 3-point measuring as well as the clamp of measuring it. Details about the poles that bringing the phone into your building. Couple of details details about direct buried cables. Details about concrete encased conduits with conductors inside them. The manhole. Details about your manhole. Talk about these babies. Okay, what else? And a few details, guys, about the base for lighting base. I can't emphasize the ground rod, guys. 5/8 of an inch, 8 foot. Great application to absorb lightning or to protect from lightning. Couple of impedance measurement or resistance measurement for the ground. Different applications. And the rest, guys, are conversion between different systems and what's not. Trade sizes, metric designators versus a trade size. Same thing with actual knockouts versus measurement is different. The boxes, guys, we have a trade size boxes, 4-inch, 1 1/4 deep, and what's not. And of course the prefixes that we can give to certain values and the conversion between the units. Any comments, my friends? Any questions? Any comments, guys? Any questions? Comments, questions? So please, as we wrap, guys, please make sure you look at these pictures. I will be going over these in details. Like I said, Derek, when it came, the book that we have, guys, have 20 chapters. Each chapter will be taking part of this project and analyzing it a little bit. This project is an industrial project directly related to what we did. What we will be doing, guys, it will tell you about the ducts, what is a bus duct, plug-in, and what's not. So it's really nice book to go. Very simple, easy to read, nice book. Any comments, ladies and gentlemen? Any questions? Comments, questions? So that's what I always have, guys, for you. Based on my plan, I do have to go over chapter 2 tomorrow and one more calculation. So yesterday, just to wrap up, see where we are. Yesterday, everybody, guys, my expectation is by Friday, everything will be set up. Did you guys go on sheet number 1, E1? Did you type or arrange the E1 through E14 in a nice format and what's not? And set them up E1 through E14. I don't want you to print 11 by 17. I typically ask you to print 11 by 17, but I will come tomorrow, guys, and ask you to walk me through all these sheets. So we don't want to print them. Cool. The second thing that should be done by tomorrow, guys, is your Microsoft project. Please, that's easy, straightforward. Did you guys see the new one I put in the network, Karen? The new one, please modify. This is how it's going to look like. Modify used to look like this one. That one I would like you guys to print by Friday and put it there, and I will go over it on Monday with you. The third one is load calculation. Load calculation, guys, I'm going to walk you through it too, but for the time being, I want you to build the system. Build it in an Excel sheet. Okay, build it as the sheet that I gave you. But I will walk you through in details through that one. But I want you to build it now, at least build it. So most likely next week I will take an hour and walk you through that sheet that you built. So my expectation by Friday is to have it built. Put as much math as you can into it, but it looks similar to the template that I gave you. Any comments, guys? Any questions? You think we can do it? Doable? Okay, thank you.